that's 12.4. So let's go to 12.5, which is equations of lines and planes. So here's a bunch of formulas that we're going to use. Let me go ahead and I'm going to move over. I'm going to go to my Webassign, to 12.5 on the Webassign. Okay, 12.5a on, okay, so I'm at the 12.5a homework on Webassign. And let's see here. So we're looking at equations of lines and planes in 3 space. And there is the parametric equation of a line, which is this. And for this one, you need just a point and a direction vector. And so let me show you how that works with the first problem. So this first problem uses this top one. Here we have the point. And so the point is x0, y0, z0. So here, x0 is 0, y0 is 14, and z0 is -9. Okay, and you can use any point. So the idea is you have a line right here, and this is just any point on the line. So it would be okay to use a different point. That would be fine. But here they're just giving us a point, so it's kind of like use that point. And so, and if you don't use that point, maybe they'll be offended. They'll be like, well, I gave you that point. Why didn't you use it? I'm offended. So we're just going to use that point, okay, for in our parametric equations. Okay, and then the other thing is they want direction. So here they've given us another line, and this line right here goes through the point -1, 6, 3, and it's in this direction, 3, -2, 6. So this right here gives us a direction. Okay, so that's 3, -2, 6. And then we just completed our there, so that would be 0 plus 3t. That's a t. And then y is 14, that one, minus 2t, and then z is -9 plus 6t, like that. So those are the equations right there. Wait a minute, vector equation? Oh, wait. Okay. Back up for a second. Okay, this is for the second answer, okay? This is the second answer. So you just basically put in 3t, comma, 14 minus 2t, comma, -9 plus 6t. Okay, so that's the parametric equation. So that just goes in like that. So 3t, comma, 14 minus 2t, 9 plus 6t. Okay, and then for the first answer, it's asking for the vector equation. And so this is the vector equation. And then it's R0 plus TV. So that would just be, R0 would be just this point right here, would represent the point, 0, 14, -9. And then t, which is your parameter, times the direction vector, 3, -2, 6. Except let's put it as a vector. You need this one as a vector also. So we'll put both those as vectors, and with the t on the front, and see what happens. So let's see here. Vectors. Three, -2, 6. We'll submit that.
That's correct.
Okay, great. Okay, so this is the answer to the second part, the second answer, and then this is the answer to the first part right here. So this is the vector equations. That's the parametric equations. Okay, let's go to the next exercise where we're going to study more of these things. So this is parametric equation of a line, vector equation of a line. This is symmetric equations for the line. So what that is right there is if you take, okay, what this one is if you take this, for example, and solve for t, then you're going to get x minus x0 over a, which goes right there. So basically take this one, solve for t, you get that. Take that one, solve for t, you get that one. So then all of the t's are always the same, right? So then just make those all the same. Okay, and that's what the symmetric equations is. Okay, so number 2.
Wait, Brother Hirsch, for number 1, do you just enter it in exactly like how you had it? Because I did that and it said it cannot be graded.
Which one? This you got the second one right?
I got the second one, yeah.
But the first one's giving you trouble?
Yeah.
This one? This one's giving you trouble?
Did you have to actually type in equals or?
Okay, so what I did was over on the right hand side you have the menu and you click vector.
Oh, you actually have to
and then yeah, it's kind of annoying. I don't think you can just type the
parentheses
bracket. Yeah, no, parentheses is not going to work. So, and I don't think you can just type that bracket either. So vectors is going to, it shows you something like this right here. So you click on that. And then when you get to the end of this one, if you use, well, I found that if you use it kind of has this in gray at the end, and your cursor's right there. If you use the arrow key to go right, when you go over to here, it makes this solid. And then plus T, and then do this, click this button again, and then these, and then here at the end, you can just input the answer. It will add the other bracket on the other end because it wants to do that. Okay, so try that, and let us know if it doesn't work. Then let us know in a minute or something.
Do you actually have to type in R equals, or because I did the whole thing, it still got it wrong.
You don't. The R equals is already there.
Right, that's what I thought, but it's still not giving me the right answer.
Really?
14.
So 0, 14, -9, and then this is, you got this T right here?
Yeah.
3, -2, -6.
These
also have to be.
Oh, I had a negative. I had a negative on the 6. We're okay.
Okay.
Hey, don't laugh at me, Penny.
Oh, man. Miss you guys.
Yeah, dang, I wish we could be in the class together.
Be laughing more.
It'd probably be more fun, yeah, okay. So, number 2, find the parametric equations for the line. So here you have a line through these 2 points, through this point and that point. So we want to find the parametric equations, and then they also want us to find the symmetric equations, but that's multiple choice, so no big deal. Okay, so for the parametric equations, we're going to need a point. We have 2 points, that's great. And we need a direction. So how are we going to get so the question is, how are we going to get the direction vector? Or can someone tell me what the direction vector is? Say the direction from that point to that point. From there to there. What's the direction?
-7, 1/2, -4. Oh no, negative. -5 minus -6.
-6, yeah. So you're just taking this minus that. It's just like, if that's P, that's Q, you're taking the vector PQ. Okay, and then, so that's gonna be, so let's go ahead and write this down. So for the x of t, that's going to be this point here, 0 plus 7t. And then we'll use this point here. So that's 1/2, and then this is a 1/2 t. We can write it as 2/2. And then the last one is 1 minus 6t. Okay, so that's going to be the parametric form. So just put the inside part of that in there. So 7t and then 1/2 plus t/2, and then 1 minus 6t. Okay. Okay, so my Webassign says that's correct. And then for the second part, you basically just want to take each of these. So this first one is x equals 7t, and solve for t. So that would be x/7. So the first one's going to be x/7 equals. That should be how it starts out. Whoa. Okay, so none of those says x/7. So that's not. So that's not going to work. Okay, hold on. Okay, so I did this, and then I'm like, okay, I'll solve for, yes, I got this. And then x/7 equals, and then none of them starts out that way, so boo, that didn't work. So what do you think the problem is? So what I think happened is they used this point instead. So 7 plus 7t in the first slot, right? And then 1 plus t/2 in the second spot, and then -5 minus 6t in the third slot. Okay, so if we use this point instead, then we have 7 plus 7t equals x. Then that means t is going to be x minus 7/7. And so the symmetric equation is going to start like this. Now let's see here. It looks like
The second
one starts like that. So I'm going to guess it's the second one. But I probably should because that's the only one that starts out that way. But I probably should if I was, if it wasn't multiple choice, then I would go right here next. And so I have t equals 2 times y minus 1. So the second one would be 2y minus 2, which is what that one is. And then the third one can be obtained similarly. Okay. Great. So we got that one right. So number 3, find parametric and symmetric equations for the line through this point and perpendicular to both of these vectors. Oh dear. So you want to go through this point and you want it to be perpendicular to both of these vectors. Okay, so do you guys remember how to find a vector that's perpendicular to 2 other vectors? You find the direction that's perpendicular to 2 other vectors. Okay, that and that. So this is the vector 1, 1, 0. And this is the vector 0, 1, 1. A lot of 1s and 0s there. Okay, so if you have these 2 vectors, let's say that's one vector, that's another, and you want a third vector, it's your directional vector. This is the direction of the line, and you want it to be perpendicular to both of these vectors. Then what fun thing do you do? that starts with a C. And is taking a determinant like this.
Cross product.
Yeah, so the cross product. So in this section, in 12.5, look for, if it ever says, oh, you want something that's perpendicular to these two vectors, then think cross product, okay? So let me go ahead and write the rest of this stuff down, copy down the first two columns, and what's this, I plus 0j plus k, k minus, and then go back over that 0, 0, j. So that's I minus j plus k, or 1, negative 1, 1. Okay, so that's your direction, and this is your point. So what's that means x of t is what? It's going to be the point. So x value for the point plus the direction times t. So that's t. Okay, and then the second thought's going to be 3 minus t. The third thought's going to be 0 plus t. Probably don't put the 0 there. Okay, so let's put that answer in. Those three numbers, so 4 plus t, comma 3 minus t, comma t. Let's see if it accepts that. Yeah, and then the second part is we're supposed to find the symmetric equations again. So symmetric equations, you take the 4 plus t equals x and solve for t. So t is x minus 4. And that will be the first one. So it looks like there's 2 of them that are like that. So 2 of them that say x minus 4. So let's go to the y one. So that means that t is going to be the negative of y minus 3. Okay, so let's see. It looks like the second answer.
Yeah, it's the second one.
Yes, yes. My Webassign agrees. Okay. So
Billy
great.
Hurst.
Make sure you got that right, Taylor.
Yeah, hey, Billy Hurst. For the first part, how did you get x is equal to 4 plus t? I get you do the cross product, and then you, yeah, that part
Okay.
there.
Okay, so this part comes from here. The x0 is come from the point, and the a is from here.
Okay, so it's part of the equation.
Yeah, and so that's how that went into there. So it's part of this right here. And then the b is going to be negative 1, and the c is going to be 1. And the y0 is 3, and the z0 is 0.
Got it.
Okay? Okay, great.
Hey, Brother Harris, is it
Yep.
A, B, and C? Is it always the direction or depends?
Yes. Yes,
Okay.
it's always the direction. In this case, yes,
Okay.
the direction. And one interesting thing is that, okay, so if we had done the opposite, then this would be negative 1, 1, negative 1. And, but that would also be correct. You could also, if you wanted, technically, you could slip in a 4 here, 4t, 4t, 4t. So you could multiply all of these by some numbers, because like the direction, so what I'm trying to say is that this is not the only vector that's going to determine the direction. So like 2, negative 2, 2 also determines the direction, right? And also if you reverse these two, and then you would get negative 1, 1, negative 1, that's also the direction. So that would be different coefficients on these t's here, but it would still be would still represent the symmetric equation, the parametric equation. Of course, the second part would give you trouble because they want you to kind of do it in the standard way, in the way that they set up, you know, they made it all ready for you. Okay, so let's go on to number 4. This is, let's find the parametric equations for the line through this point that is perpendicular to the plane. So here we have a plane, and there's one thing that I will just tell you right now, but we'll show you later. I don't know if we'll get that far today, but about planes, okay? And that is, if I go back here to the first, if I go back here, right here. So if you have an equation of a plane, like that or that. So these two are equations for planes. There's this equation and that equation. And you'll notice that there's these coefficients A, B, and C, and the A, B, and C there. The only difference is that this has been expanded out. These A's and the B's and C's have been distributed, and then everything here collected, okay? So you still have an AX plus BY plus C in here that's gonna come up from here, because X0, Y0, and Z0 are just numbers. Those are gonna be fixed numbers. Okay, the normal to the plane is this vector here. Okay, so that's the point I'm trying to make. So that means that right here, the normal to the plane is 1, -1, 3. So I'm just taking the coefficients of the X, the Y, and the Z. So 1, -1, 3. Okay, so if you have an equation of a plane like that, that's the normal. That's also the perpendicular. Okay, so this is actually going to be the direction of my line. Okay, so here we have a point and a direction. So what's the equation? What's the parametric equations? What's in the X slot?
Is it 4 plus T?
Yes, 4 plus T. So this point here, 4. And then this is a 1, so it's just going to be 1T. Which is just T. And then what's the second spot?
It's going to be 3 minus T.
Yes, and then the last one?
It's going to be 6 plus 3T.
Yes, okay, so let's put those in and see if Webassign says anything. Okay, good. Okay, now, the second part, part B says, at what point, so here's part B. At what points does this line intersect the coordinate planes? Okay, so the first one is, where does it intersect the XY plane? Okay, so the XY plane, so if we have, think about this over here. So we have the Y there, we have Z there, and then we have X coming out this way. So the XY plane is just stuff down here. Now, every single point in the XY plane has what property? Every single point in the XY plane has Z equal to 0. Okay? So z equals 0 for every point in the xy plane. Okay, so what we're going to do is here, this is our z. We're going to force that to be 0 and see what happens. So what do we get? What value of t is that going to give us?
Equal to negative 2.
That's negative 2, right? And so if we plug in, so you plug in negative 2 here and here, then that's going to be 4 minus 2, and then this is going to be 3 plus 2, and then of course this is going to be 0. Wait. Wow, I said, whoa, what skill? I said 2, and I wrote a t. Wow. Okay, so 2, 5, 0. Okay, so let's put that in there as the point that it crosses the xy plane. Okay, and then the next one is where it crosses the yz plane. Okay, that said that's correct. Yay. Okay, so now for the yz plane, what do we do?
You set the x equal to 0.
Yes, and so that's like taking the 4 plus t and setting equal to 0. That gives us t equal to negative 4. And if we plug that negative 4 into the thing, it gets 0. And then this is going to be 3 plus 4. And then this last one's going to be 6 plus, 6 minus. If you put in a negative 4 here, that's going to be minus 12. Okay, so that's 0, 7, and negative 6. Okay, so 0, 7, negative 6. And then the last one, you're going to set y equal to 0. Okay, so for the Xy plane, you're going to set y equal to 0. So that's this middle one. So t is going to be 3. And so you're going to get 7. I'm just putting 3's in here. So that's 7, and that's 0. And that one is 15. So 7, 0, 15. We'll try that. Okay, great. That's number 4. So number 5, it says determine whether the lines L1 and L2 are parallel, skew, or intersecting. Okay, so you know that that if you have 2 lines in space, then they could be parallel to each other. But then one of them could be like this, another one like that, but underneath it, you know, underneath it. And that's skew. Or they could just be on the same plane and intersect. Okay, so either parallel or skew or intersect somewhere. Okay, so here we have one equation. These are the parametric equations, like here. And for the second line, they're using an S instead of a T, but it's just the same. Whether you use an S or a T, it's just the same. This is still the parametric equations of a line, even though it has the S's there. And now it's just functions the same way that the T does. And the reason that they're putting S's here is because so you don't get it confused with the first line, okay? So that you can like keep these apart from each other. Okay, so to the first question, are they parallel? And then to be parallel, what do you think needs to happen? Well, the direction vectors, they should be multiples of each other. Okay, so for L1, the direction vector is 6, -3, 9, everything here is divisible by 3, right? So this could be like 2, -1, 3, or like this could be the direction vector. Okay, and for the second line, the direction vector is 8, -4, 10, right? So let's see, 8, -4, 10. Okay, so this is divisible by 2. So it could actually just be 4, -2, 5. Okay, so there's no way these are multiples of each other, because if you divided this by 2, then you would get a 2, -1, and you're like, whoa, they're the same as these two, but then this would be 5 halves, and that's 3. So no, so they're not parallel. Dang it, I've used up all my space. Oh, maybe I'm just tempted to guess. Do they intersect? Okay, now, do they intersect? That's another question. So to determine if they intersect, what you're going to have to do is set these things equal to each other. So the idea is to find values of t and s where that equals, those are equal, and then where the y values are all equal, always, and where the z values are all equal all the time. Okay, so you're going to have to find, so you're going to have to be able to, if they intersect somewhere, then they're going to have to be able to find the value of s and the value of t where all these equations work. Okay, so let's see here. That one, dang, this looks nasty. So that's 6t minus 8s equals -7. Okay. This next one is 3t minus 4s equals 6. And this one is 9t minus 10s equals 5. Right? Is that right? Okay. Okay, I can tell already that these first two, there's no way that you can even solve these first two, because if you multiply this one if you multiply the second equation by 2, you get 6t minus 8s equals 12, right? So you can't have 6t minus 8s being equal to -7 and simultaneously it being equal to 12. So right there, that means there's no solution. So that means that they're skew. Okay, so they're not multiples of each other. The directions are not multiples of each other. And then there's no way you can solve this. And so then don't intersect. So that means that they're skew lines. And then in the second part, you're going to put D and E. Okay, skew and D and E. Okay, so those are going to be your answers there.
Hey, Brother Hurst,
Yes.
if they were to intersect and it's asked for the point of intersection, would it be just the value of t and s or something else?
Okay, so you would have to take the value of t. You could take either the value of t or the value of s. You'd have to plug it into here. So basically what you would have to do is plug in value of t into here, and here, and here. You'd have to plug it into these spots, and this would be your value of x. That's your value of y and z. So your answer should have 3 values, x, y, and z. And if they, so you're in the end, you'll get a value of s and you'll get a value of t, right? If you plug the values of t into there, then you should get the right answer. Or if you plug the value of s into here, you should also get the right answer.
Okay.
Okay,
Thank
so
you.
either way, those should be the same. So that's the way you can
Okay.
double check yourself if you wanted. Okay.
Okay. Thank you.
Great. Great. Okay, so let's go on to the next problem. So here we're getting into equation of a plane. How about, there's not very much time left, but let me just explain how this works. Okay, so you want the equation of a plane that goes through the point 6, 5, 6. Okay, so so let's say here's your point in the plane, and in this case the plane is 6, 5, 6. Okay, and again, I'm not gonna really worry about the position of this point relative to the axis or anything. So just think of this point as lying in a plane here. So here we have a plane, and it has edges, but this goes on forever and ever in all directions, right? Okay, now you have a normal vector to the plane. So that's a normal vector right here. Now, if you have another point in the plane, and you draw the vector from P to that other point, we'll just kind of call this a general point in the plane, X, Y, Z. We'll just kind of call that a general point. It could be anywhere. But every single point, this vector from P to that point, every single point in the plane, the vector from this other point in the plane, so remember this point's in the plane, that's P, that's your P right here. This is 6, 5, 6 here. This vector here is perpendicular to the normal vector, right? These are perpendicular. And the if that's point, say a point Q, then the vector from P to Q is going to be, if the coordinates are X, Y, Z, and these coordinates are 6, 5, 6, then what is this vector P from P to Q? You just take this one and subtract that one from it. So it's 6 minus X, Y minus 5, and then Z minus 6 is that vector, right? Okay, so here's the big question right now. What is a really interesting, what's a really convenient thing relating this with the normal vector? Okay, so maybe I should just come out and tell you. What happens if you take the dot product of the normal vector with this vector? What happens if you take the dot product of this vector with the normal vector? What are you going to get? You guys remember? These two vectors are perpendicular. What's their dot product going to be?
Do you have to change from
0.
negative to positive? Or thinking of something else?
Well, there's 2 ways to calculate the dot product. Okay, so if this is the vector 3, so the normal vector is 3, 1, negative 1, right? And this vector is PQ is this. What's the dot product with this and this? That's going to be 3 times the first one, right? Plus 1 times the second one. plus -1 times the third one. Also, that's going to be 0. Okay? Because these are perpendicular. Now, this point Q could represent any point in the plane with coordinates x, y, z. And so for any point in the plane, this is gonna happen. Okay, and so this equation here looks like this one, right? And it looks like this one too. Okay, so that's how the equation of the plane works. And I guess we could take this right here, distribute the 3, so 3x minus 18 plus y minus 5, distribute the -1 minus z plus 6 equals 0. And then we have that. We combine these other 3 together, so that's minus 17, I believe, equals 0. And then put that in and see if that works. So 3x plus y minus z minus 17 equals 0.
Wow, it worked.
Yeah, so that works. So that's the equation of the plane. And so that's why before I said you can get the normal. If you have this kind of equation right here, you get the normal by just picking off the coefficients 3, 1, -1, which is the normal here. Because of this relationship right here, the dot product of orthogonal vectors or perpendicular vectors is 0. Okay, that's the key. The dot product of the normal with this other vector is 0. Okay, great. That's all we have time for. So any final questions before we end the meeting?
So you get the direction and multiply it with the normal vectors. Am I correct? And then equal to 0?
Mm-hmm.
Okay.
Yeah.
Thank you.
Well, yeah. The direction is just, well, this is an arbitrary. This is also an arbitrary point, x, y, z. And
Okay.
but any arbitrary point, it has to satisfy this when you take, like if you had another point, like if you had another point over here that's also on the plane, okay, then it's also going to be normal to this. It's still going to be normal to this vector. If you have a point over here, it's all these points in the plane. If you look at that vector from this point to that point, and its dot product with the normal vector, it's going to be 0. Okay.
Thank you. Yeah. Thank you.
So, sure. Okay. Well,